Welcome to episode 30 of the Brainstorm, first one of 2024. And we've got a big topic, the convergence of AI and robotics. A lot of action just over the past week. Brett, you put out a very provocative chart forecasting general AI before the end of the decade. There's obviously a lot to dig in there. Probably first is, what is AGI? How do you define it? And then we can go from there.
Yeah. So AGI, artificial general intelligence, is a term that gets thrown around a lot. And in some ways it's problematic because people have different definitions of the term. And there's, I think there's a universal thing that occurs when once technology crosses a certain threshold, then we move the goalposts of how good technology has to get. And so the chart I put out is drawing from data from a site called Metaculus that is a forecasting site. And there, the questions are sufficiently specified that they can be resolved. So the chart shows that time to AGI on a specific definition, which I'll get into, has fallen from its 50 to 80 years away in 2020. That was the forecaster's estimation, to likely by the end of the decade. And so it's fallen from 50 to 80 years to 30-ish years to 20-ish years to now the most recent data point, it's a little less than 8 years away. And if the forecasts were well tuned, it would actually diminish by 1 year every year. But instead, it's clear that essentially the capability of intelligence systems, of these artificial intelligence systems, is actually catching people off guard. And so, if that forecasting error continues, basically, if GPT-5 is actually that much more performant than people expect it to be, then it could be as soon as kind of 2027, 2028, when by this definition, an artificial intelligence, general intelligence system would be available. And so kind of that's the overall view. And then it's important to recognize that, this definition, as with all other definitions of artificial general intelligence, will, once the threshold's crossed, people will probably move the goalposts again. But this is a really tricky and challenging kind of benchmark that's been laid out. So the system has to be in an adversarial conversation with a human for 2 hours, where the human is really trying to determine and demonstrate that it's a not human system by throwing whatever they want at it, audio, video, kind of basically interrogate it a la Blade Runner to find out whether or not it's synthetic. And it has to pass that. It has to pass a lot of kind of question answer logic puzzles, basically be expert in a lot of different areas and able to pass tests, kind of accreditation type of tests in those different specialty areas. And germane to this discussion, it has to be able to, if you give it the right robotic actuators, it has to be able to put together an intricate car model using, it's hundreds of pages of instructions to put together the car model. And I would challenge anybody to look at those instructions and say, that's easy. It's actually, I'm not sure I could do it, at least not without a lot of putting the wrong piece in the wrong place or kind of fumbling around with screws and everything else. So kind of the threshold that's been set is really stiff, and the time to when we achieve that threshold has been falling and seems to be falling sufficiently fast that by the end of the decade, we'll be there. And so that's the context.
That's right. It has to start this project on the model car, then be able to drive itself to Home Depot, get the parts it forgot, come back and finish the job. But just to take a step back here, all technologies, Brett, we're familiar with the hype cycle, right? How come, or I guess one, do you believe this forecast? And how do we put it in that hype cycle type of mentality?
Yes, I believe the forecast. In part, the site, kind of the forecasting accuracy of the site, they've looked at previous forecasts and how well tuned they are, is actually pretty good. And so there's reason to believe that kind of it's not just a biased set of observers. It's people who are really trying to get these forecasts right. And it covers all kinds of, it's not just AI and tech, it's also politics and all kinds of other different kind of things that people would forecast. And so I think that there's like objective reasons to believe this is a good, well-tuned set of forecasts, or at least people making their best efforts. And if you take a lot of people making their best efforts and you average them together, you actually usually get quite good forecasts. Within the context of the hype cycle, if anything, I think AI and robotics is actually still underhyped, insofar as it's very clear in the capital markets and the equity markets that people aren't really believing that this stuff is going to happen. And even for myself, like, and for you, it's like we joke about, hey, having a robot that at least could be teller operated to like do the dishes for you, and maybe be software controlled to do the dishes for you. I don't really have like an expectation, or it's hard for me to hold an expectation that I believe actually could be true, that I could, buy a robot for $20,000 or $30,000 that would do 2 or 3 hours of housework for me generally per day. Like it's the technology trends suggest that that's a spot that we could get by the end of the decade, but I don't think my own internal framework has adjusted for it. Has yours? I mean, are you ready to like spring out for a robot like 5 years from now?
Well, I would say definitely not. And I guess where I'm struggling is it's very clear that this is moving extremely quickly. Just to introduce the other topic quickly, so then we can just have an open conversation, right? The other piece was put out as a Stanford researcher along with people from Berkeley and Meta. And this was the quote, Aloha robot, low cost, open source hardware, roughly that $20,000 you're talking about. And they can teleoperate it. And after they teleoperate it to train it, it can then autonomously perform certain tasks. And so there's, viral videos of that going around, it cooking eggs and everyone getting excited about this. And so, right, I see that, I get excited. I'm hesitant just because of new technologies often get hyped, right? And then there is a plateau. And we've seen that, in the past with other technologies. I think I guess the flip side of that is right now we're kind of 20 years after the .com hype cycle. And so we're seeing the hype come to fruition with a lot of areas, right? So we're seeing that with robotics. I guess you could argue that is the 20-year lag from kind of early challenges, and you see the robot like falling over, autonomous challenge, like, are we finally there? There's been hype there for a long time. Rockets, I think we're certainly there, right? There was a huge boom and bust in the 1990s on rocket and aerospace companies. And now you've got SpaceX launching every few days. So I'm just trying to tune where we are with this.
I think there is a real difference with artificial intelligence. For one thing, it's so interconnected with the other technologies, as in across all of our areas, all of our forecasts get accelerated if artificial intelligence accelerates. As in, even at call it end of last year, when we were going through kind of our big ideas production and talking about modeling, and there was still kind of like debate, call it, that was kind of like humanoid robots really a post 2030 thing that was going to occur. And for me, I was like the mechanical actuation side. Hardware is hard, and I thought that could be just a gating factor, as in you could have a software that was good enough, but then having hardware that's precise enough and that can actuate in a fine-tuned way sufficient to fry you an egg or fold clothes, which is still like a really challenging problem, by the way. It just seemed unlikely that we were going to get there. And two, it's kind of like the software control of the robots. We're beginning to see evidence that AI was accelerating. But now I'd say that there's even firmer evidence that the capability of AI systems is going to explode. And so even relative to other hype cycles where it's like people overestimate what's available in the short term, but underestimate what's possible in the long term. Well, in traditional tech on Moore's law, the short term is maybe, 2 years out, which is a cost halving, right? Mm-hmm. And in the long term is 10 years out, which is, 5 consecutive cost halvings, right? In AI, the the cost halving is happening every 6 months, at least on a cost to train a network. So a forecast that's 2 years out is the equivalent of a forecast that's 8 years out in traditional tech. So I actually think it's harder for the hype cycle to get on sides of the reality right now because of how quickly things are moving. Like there was a video on X the other day of like construction of an internal combustion engine and how precise it is.
Yeah.
And
it's like the last is the best. Right.
Exactly. You get so optimized. Like there's so much engineering magic has gone into creating a V8 engine, and it is so precisely optimized. You can imagine it's hard to change any individual part because you've just distilled into this is the perfect form factor for this thing. And so any marginal improvement requires like monumental engineering effort and billions of dollars of traditional automaker R&D. Whereas with AI, people are still like, oh, if I ask this thing in a slightly different way, I get a 5% improvement. And so it's clear we're not optimized. And that signals how early we are, I think.
Okay, so then what do we do? AGI is coming within the next 6 years. Okay, I guess when did you start to believe that this was the case, right? If we're just taking the conversation, clearly there's been a difference between last year when we were doing big ideas around this time to now. And so now with this added information, what does that change? Does that change anything in your day-to-day life or just in your investing theses?
Well, I think I'd be careful because I'm not sure I believe that going back to like the general, the moving definition of AGI, I think that you will have extraordinarily capable intelligent systems and mechanically actuated systems, which I think is more where the adjustment has happened for me. But that does not necessarily mean you're going to have like agent-like systems that are kind of like cascading upward and making decisions, at least within that time frame. So I think that there is, potential architectural improvements you need to make to AI systems to really prompt a series of agents who are really making kind of executive level decisions and kind of optimizing resources in a way that exponentially scales. So with that as the caveat, I think, I'm going to turn the question around to you. Do you really believe that like a humanoid robot is going to be something that is in people's households, call it the not 10% penetrated, but between, up to 5% penetrated by the end of the decade?
End of decade. I'd say I'm still skeptical by end of decade, but on the manufacturing side, I think it's going to be very dramatic, right? Like I think even within the next 5 years, right, you cross that point and you get these I'd say factories are more structured environments than people's homes, probably less variety. You can design systems and new warehouses around them, right? If you look at how Amazon kind of rolled out their robotics, it's like they build a new warehouse and it's like, all right, we're going to test stuff here. If it works, then you kind of do the next implementation with the next warehouse. So I think it definitely starts in the warehousing / manufacturing side of things, and then gets into people's homes maybe 2030 to 2040. That's the big story.
So it would start just because like manufacturers are willing to like upfront the cost for an expensive piece of kit that's going to like wrangle around in their warehouse. Is that because I think the alternative argument would be that, so many of these manufacturers, look at the OEMs. It's like they can't, the automakers, they have optimized systems already. And it's like, oh, now we have to do a CapEx cycle. It doesn't fit in with the fact that, we already have all of these systems in place. And probably these robots are going to start out looking like worse at any specific task, but generally capable. I don't know if you agree with that, where it's kind of like, well, I can't plug in to this specific automation that I've already designed because it's already optimized. And so then what do I do with this robot that's kind of like the bumbling intern robot? and so it kind of like becomes a feature that people that already have designed manufacturing systems experiment with, and they're like, there's no ROI here, so then they don't buy. Whereas a household, if I could use the Aloha robot, like $20,000 to $30,000, and even if the software is not yet up to snuff, I can like have somebody in a very low wage country teleoperating it. Like that might be like a great ROI for me today if it can fry me an egg. I mean, right. Couldn't that be the other way in which we penetrate?
Yeah. I mean, I think that gets into a very interesting discussion around bottlenecks, which is, I feel like one that we've had is, right, the hardware is like, okay, hardware is going to be an issue. But then you've got a big player like Tesla. You've got Figure AI, who's also going vertically integrated. And it's like, once the opportunity is there, it's like we have the technology. Someone just needs to invest in it. And it seems like that's being done, right? The robotic hands on Optimus in the most recent video were pretty impressive, I would say, as far as fine motor movements. And so then I think the software side is that bottleneck. And then it's a question of tolerance. So I think there's like easier skills to accomplish in manufacturing that are useful, picking up a box, moving it, than there is at home. Whereas I don't think, right, if you're counting on a teleoperated robot to make you something, and then you wake up and there's a malfunction and there's a hot egg on the ground and there's an open flame on your stove, right? You're not gonna be so willing to continue down that route.
You think that doesn't happen with my kids? Because like, I mean, it's been plenty of like spilled milks and broken plates in our household.
Well, I've always been surprised of like, let's just go iRobot and the Roomba. It's like, that is a bad product as far as I'm concerned. And like, people have them, they sell a lot of them, and I guess people use them, but I've actually never gone to someone's house and had them been like, wow, this Roomba is great. It's running all the time, as opposed to here it is in the corner and it has no battery and it's never used.
Yeah, that's an interesting, I think, case study. In conceptually, that should be something that works. And the reason it doesn't is because the technology is bulky and it doesn't actually, there's much more to cleaning than just vacuuming. Do you know what I mean? Like if you have a cleaning person come in, they're vacuuming, they're dusting. And so it doesn't necessarily solve your problem, because then maybe you're doing the dusting yourself, but then the vacuuming is kind of like subpar. I agree. I've never had anybody like advocate for me to get a Roomba. And I don't anticipate I ever will. So why would this be different? Won't there just be people that have like a robot that's sitting in the corner and they're like, well, I bought it. It didn't really do anything.
Yeah. I mean, that could be the case. I guess the price point matters. I do think it's interesting the way it's going to accumulate data and learning, right? And so, with the Aloha robot, they're saying they do a task 50 times and it learns. And so maybe that is a clever way to get data, is you do this teleoperation made service and it's constantly training. But I think that data question is harder. And it's like, you will learn to move through space, right? That's clearly Tesla's angle. They're going to take kind of the FSD and everything they've learned there so they can have a robot move through space. But I think there's probably unique and varied learning. That's probably hard corner cases to get.
Yeah, I guess I take the other side of that a little bit in that it is the hope for, like, why does the Roomba not get advocated for? It's like you buy a Roomba, that Roomba is as performant as it will ever be the first day you get it. Then it slowly gets clogged up and then it like stops working and then it ends up in the corner and then in the trash. Whereas kind of these robot systems, the more of them that a single entity has in place, the more data it will have. And we now have like a very clear pathway to taking like large amounts of data and converting them into large amounts of capability. And so you just need a threshold level of mechanical actuation to be crossed. And some kind of like chipset in the like you might be constrained by the chip you've stuck in the robot's head, And so maybe you need a pathway by which to like upgrade that chip over time. But like conceptually, the breakthrough in AI is really a breakthrough in every problem I have, every corner case I run into has the same solution. Before it was like, I want to train a robot to crack an egg. It's like, I have to come up with a unique software solution to egg cracking and figure out all the heuristics of like, oh, what do I do if the egg falls on the floor? What if I, like think of all the if then statements you needed. And so every unique problem had a unique solution. Now it's like every unique problem has the same solution. You throw data at it and you throw compute at it. And, given enough time, you end up with an egg flipping robot. And it means that the hardware that gets shipped is not hardware that's going to just remain as performant as it was before. People love Teslas because, hey, like the mapping system on Teslas just improved last week. That's great. It's amazing. Now I can see where the traffic lights and stop signs are, which are good for like, telling whether or not a route is one I really want to drive, right? But that's like a minor piece of what a Tesla does. A Tesla still like drives like a car, whereas these robots, like, the upgrade might be, hey, now it folds my laundry before it was only doing dishes, right? And on the same piece of hardware, that's a very different kind of, it's really a different kind of product to what people have purchased before, where kind of like the mechanical behavior of the product could be improved by the software in kind of profound, kind of like opportunity enabling ways.
Yep. And then maybe just as we wrap up, right, why is this so huge to have in the house? Just from the time of use survey, they say 1.89 hours a day are spent on household activities. Another, let's say 45-ish minutes spent caring for and helping household members or non-household members. So that's a fair amount of time. We'll call it 2-ish hours a day of things you're doing that could probably be easily replaced. You could imagine even just the teleoperated robot or something helping a grandfather off the couch or calling the police if someone needs help, right? That's like the Apple Watch solution there. But the physical element, right? It's like help them get into the bath or out of the bath, something like that. That's a big market as well.
Just opening all the Amazon boxes that come in. It's like a big deal. If I had a robot that would just take out the trash bins out to the curb, this is an LA problem. But man, that would be, in cramming the cardboard into the trash, there's all kinds of things I could use one of these things for. So they better hurry up. Given an hour of saved labor, what do we think that a consumer would spend in terms of like a trade-off for a robot being able to do it?
Yep. So typically, well, actually, there's a study that we base this off of, but people typically value that free time at 50% of their hourly wage. And so you can see how by country and by individual this could vary. So, Brett, maybe we should get you this robot and we can start experimenting.
I'll have you teleoperate it, and you can. I'll perch it in front of the keyboard, and you can write my emails for me.
Yeah, exactly. Efficient. Just one button at a time. But yeah. So let me just pull up some very high level numbers. What do we think this opportunity is? This is for this at home. I think we think that's around $12 trillion in valued time annually. So that's a big number. And that's time that's currently not really captured well by existing services.
Yeah. And actually, so then you asked, like, how do I think practically about this or within the context of my life? I do think that the combination of kind of robotaxi and this robotics opportunity are both innovations that are going to directly impact measured GDP in a profound way. As in, think about that time saved on doing dishes or whatever. I do the dishes. I don't get paid for doing the dishes, right? And so it doesn't appear in the economic statistics. But if I'm making a trade-off where I'm buying a robot to do it or renting a robot or whatever, then suddenly I'm paying for the service and I'm using the time to talk to the likes of you instead. So I'm being economically productive kind of from a work perspective. And I'm then paying, the additional wages I get, I'm using to pay for a service. So you have non-market labor doing the dishes, or in the robotaxi example, like driving your car around, that become market services. And that's like within the context of innovation, it's actually a lot of statistically productivity generating innovations like follow that same characteristic. The housewife in the 1950s who was having to spend all this time doing laundry, and you probably have the number on the back of your hand, that then buys a washing machine, saves, it was like hours a week doing laundry, right? And so then she can enter the labor force. And the paying for the washing machine shows up in GDP. And so like when you combine all of that, our expectation for GDP inside ARC is that we're going to go from, we're kind of like a little over $100 trillion GDP global on a real basis this past year, and going to go to 170 trillion by 2030, relative to a consensus expectation of around 130 trillion. So GDP per capita on a real basis goes to 20,000 per capita as opposed to 15,000. And it's supported by kind of like looking at the way in which GDP is structurally changed, GDP growth is structurally changed over time, where we're not just at the same growth. Like periodically there's these bursts of innovation that change the equilibrium level of growth. We think we're going from 2 to 3% up to like a 7 to 10% range by the end of the decade in terms of a real growth. And it's because suddenly you have these robots that can, you install them in place and then they can take on more and more activity. They can take up more and more of the household time. They free up people's labor. You have robotaxis that are like probably going to be safer, cheaper, and certainly more convenient to ride around in rather than driving yourself. And so kind of there's going to be a huge kind of macroeconomic unlock. And so within, it really suggests we're going to enter an age of abundance where all of these kind of like physical goods that are manufactured or physical feats of getting things from place to place are going to become much more economical. And so prompt a lot more activity, a lot more things will be done.
Age of abundance is good. I feel like that's the fun part of all of this, all of the convergence. There's always like, oh, one more thing about this, right? There's another thing to model, dimension. Same thing here, right? People say, oh, like, are people going to redesign everything around a humanoid robot? And it sounds ridiculous now, but actually that's the history of automation and innovation, is something comes along and then the whole world kind of reorients around the new, efficient, useful way of doing something. So new industries will be created, and it will be exciting to be along for the ride.
Well, and those that don't adapt quickly enough will die. Like, I think that's the other reason to believe that kind of the hype cycle has a faster realization period this time around. Is, again, like imagine you have two manufacturers, one who has a really optimized system. They're manufacturing V8 engines, and they say, hey, we don't need to change this. Like, we can't wring any more efficiency out of it. And another that is kind of like approaching the market anew and saying, well, actually, if we have a really flexible manufacturing process, we can develop all kinds of different form factors here, because the robots in our assembly line are not optimized to specific tasks. So it's like, maybe it's drones. And so you can make drones of all different sizes, all specialized for the specific thing they're going to plug into. And that was not possible before because economically it was out of bounds. And at first, like maybe that manufacturer is making a bunch of stuff that's like, it's really not as good as an optimized manufacturer. And so it's kind of like they find little niches in the market, but it looks like it's a more costly way to produce stuff. But the robots in their system are going to improve, and they're going to improve, we think at something like at least 3x per year, because that's the cost decline in AI systems. But you cross that with like more investment in AI compute, and you get to, 10 plus X a year. And so at first, the manufacturer going about this saying, I'm going to like embrace these general purpose robots to try to like make a bunch of stuff, might look like they're struggling. But over the course of 2 years, suddenly you have it's like a 100x improvement in what they're doing, whereas the previous optimized manufacturer is still like treading water. And so there really could be a upturning of those companies that aren't agile or aggressive enough at deploying these technologies in a much more rapid fashion than you've seen in the past. We will see.
That's right. Wow. Check in next week and we'll see what else happens. That's right.
Yes. It won't happen next week, but like over the course of 5 years, and this is really, I think, the challenge with technology is it always seems like it's kind of moving. And then you go forward 5 years and you look back and you say, oh my gosh, we're really here with this thing. And in humanoid robots, it's really been kind of like a transformation on the actuator and mechanical side just over the past year and a half, I'd say. And so now, will the software improve enough that it really is kind of doing the dishes for me, which is my dream.
The dishwasher is already a robot.
This is a good point. Somebody has to load the dishwasher. This is the problem.
Exactly.
And the pots don't fit in the dishwasher. I need somebody to scrub pots and pans.
It's
Please.
True. It's true. All right. Thank you, Brett, for a great brainstorm. And I'm always excited about the future, but I'm very interested to be 5 years ahead and to look back, and we can revisit this and see where we are.
Yeah. And bookmark this. All right. Thanks, Sam.
Bye.